how about the line of intersection between two planes? So let's just assume we have two planes, this one, and now we want to do you want to have an intersection. So you just put two planes into each other, and let them intersect. And when you have the intersection, then maybe you can see it. Can you see it? We have this sort of a line of intersection at the intersection, right? Ideally, of course, this should be like this. Then you see there's a intersection line, and I'm going to show you how you can calculate that. It's actually not too complicated. It's always the same when you have intersections. When you have intersections between A and B, then you have to assume A and B is the same. And then the calculation will show you where this assumption is valid. So this is always the point about those intersection calculations. I will show you with an example how it works. How to calculate the line of intersection between two planes. It's actually, I just thought about it, it's quite easy. You just have to understand the principle, and you should know how to calculate a linear system of equations. So first I'm going to show you the principle, therefore we need two small papers. So we assume that these two small papers are our planes, and I'm just going to facilitate the demonstration a little bit. So what we want to do is we intersect our two planes. Come on, intersection here. Can you see it? And we call this is a little bit difficult. So we call the line of intersection here, this intersection line. Maybe you can see it right there. I can also make it maybe bold with a felt pen. We call this line here in between. It's a little bit difficult, more difficult than I thought. So we call this line, can you see it? This line between the two planes, that intersection line. We call this line, of course, intersection line. But this we want to calculate actually. So we want to know what's the mathematical expression of this line of intersection for a given set of two planes. And how we can calculate that I'm going to show you in a second. So the principle is actually the same as with linear functions. We just have to combine the definitions of the two planes. So we have to make sure that that both planes are valid at the same time, and we have to combine the definitions a little bit of those two planes. But the principle, I hope you can see from this little demonstration. So we want to calculate the black line, which is the intersection line between those two planes. So I'm going to show you how it works with an example. So two planes, one is called E, and note that both planes in this example are given in the coordinate representation, which is a big advantage for this type of calculation. I'm going to show you in a second why. Minus 9x1 minus 4x2 plus 6x3 equals 1. F is minus 6x1 minus 7x2 plus 4x3 equals 8. And the big advantage is that the coefficients, these ones, the coefficients are for each plane the normal vector. So just by looking at it, we can tell the normal vector. This is a big advantage, since that's what we are going to need for the calculation. And actually, maybe if you're familiar a little bit with the Gaussian algorithm or with matrices, you can also tell just by looking at it, it looks already like a system of linear equations. And how to do it is we just transfer all the coefficients and also the numbers on the right side into a matrix so that it gets a little bit easier to calculate. I'm going to show you how. So minus 9 minus 4 plus 6 and 1. Minus 6 minus 7 plus 4 and 8. This is a matrix. Actually, in this case, we cannot fully solve the matrix, since we know for 3 variables we also need 3 informations, that is 3 lines. In this case, we only have 2. So we know already before we start solving it that we lack 1 information, so the solution that we get out of the matrix will depend on a parameter. If there's a solution, but obviously, of course, in this case, it's an example. And it works quite well. I already tried it out, so 1 and 2. Those are our 2 rows, our 2 equations we want to solve together. And now we just apply the Gaussian algorithm. So we say, in this case, it's a little bit, the calculation is a little bit ugly, but we can do it just by calculating straightforward. So I say 1a, I want to put those 2 together. And I say 1a is 1 minus 3 divided by 2, 2, right? So I get a 0 here in the front. That's what I'm going to do. So as I just said, 0 in the front, and for the rest, to make sure that I don't make any mistakes, just use the calculator. If you have a calculator, perfect. If you don't, then it's a lot of calculation in this case, but maybe the numbers are good, so it's easy to calculate by hand. Basically, you can do it by hand. So we have minus 4 minus 3 divided by 2. Wait. Missed a minus. So minus 3 divided by 2 times minus 7, which equals 6.5. Again, I have 6 minus 3 divided by 2 times 4. Which equals 0. Very good. I want to have 0. Zeros is always good. Or 1s. 1s or zeros is perfect in the matrix. Then, right side, I have 1 minus 3 divided by 2 times 8. And I end up with minus 11. First row finished. Second row, we can do something. And 2a. And what we can do is we say we want to make a 0 here, right? Because here we already have one. There, x3 we also have a 0. So where we want to have a 0 also is here in the middle. So we take 1 minus 4 divided by 7, 2. It's quite straightforward, but of course with the fractions it looks a little bit ugly. But if it's straightforward, you can just calculate it. Just do it. Also, even if the numbers don't look nice, but you can do it. Just straightforward. So again, 2, as I said, I take 1 minus 9 minus 4 divided by 7 times 2, which is minus 6 in this case, and I end up with a strange number, but I can let the calculator show me the fraction, which is minus 39 divided by 7. And I go ahead. I can just make, just prove, but I said I want to have a 0 here, and of course there's a 0, so I have minus 4 minus 4 divided by 7 times minus 7, and of course, as I said, I end up with 0. Then I have 6 minus 4 divided by 7 times 4, and I end up also with a strange number with 26 divided by 7, and again right side, 1 minus 4 divided by 7 times 8 is also a strange number, minus 25 divided by 7, minus 25 divided by 7. Now actually I'm almost finished. I can make it look a little bit nicer, and I say 1b is 1a divided by 6.5, and I say 2b looks nice, I just say 2a times 7. So I have 1b, 0, 1, 0, minus 11 divided by 6.5, and I end up with, also looks strange, minus 22 divided by 13. And with 2b, it's much easier. You can just take the 39, 26, and 25. So minus 39, 0, 26, and minus 25. So for now, it doesn't look too bad. A little bit, one fraction, but that's okay for now. And now we really want to know what is x1, x2, x3. From this we can already see, okay, we have to introduce a parameter. Of course we knew already from the beginning, but now we really have to introduce the parameter. And usually I insert it from either x3 or x2. In this case x2 we already know, so I say x3. I say a parameter called t element r, so it's a number, not a vector. x2, I already know, I can just take the value, minus 22 divided by 13. x1, that's a little bit more complicated. I have minus 25 on the right side, so I say minus 26t, since I know x3 is t, right? And then I divide by minus 39, so minus 39. And now I can make it a little bit look better, and I end up with, of course I can cancel out the minuses, and then I end up with 25 divided by 39 plus 26 divided by 39 is 2/3, so plus 2/3 t. And that's my solution for x1. So now I have actually all my components, and I have one parameter, which is quite good, since you may remember a straight line has one parameter, has one variable, right? One letter we don't really know. And that's good because, of course, a straight line consists of many points, and with the variable or with the parameter I can show all these points. So we just have to write down the solution now, and we call it g, which is, we just have to write it down, right? Which is 25 divided by 39 plus 2 divided by 3t, first component. Second component is minus 22 divided by 13. Third component is t. And now what we are going to do, we want to separate things which are connected with a t and things which are not connected with a t. And then looks the following. So we have 25 minus 22 divided by 13 and 0 plus 2/3 t, 0 and 1t. Then we can also put the t in front of the vector, right? We can write 25, oh I forgot something, 25 divided by 39, 25 divided by 39, minus 22 divided by 13 and 0. Then just put the t in front of the vector, then we end up with t 2/3, 0, 1. And this is already our equation for the straight line. This is our line of intersection, so it's not too difficult. If you look at the two planes, you just have to write it like this, and then you see already, okay, you can write it as a matrix. When you can write it as a matrix, you can already solve it, and you see you have two informations for three unknowns, so you know if there's a line of intersection, then it has, if there's a solution, then it must contain a parameter. Usually it could also be that maybe you have some zeros in between, so you don't need a parameter, but most probably if you calculate a line of intersection, you will end up with a parameter necessary in the solution. And maybe the calculation gets a little bit ugly, maybe you have a better calculator than I have, then you can of course put in your matrix in the calculator, solve it easily, and just write down the solution. In this case I showed you how to calculate it just with your hand and brain, and then write the solution as a straight line. Then you have to separate the t's from the non-t's from the not t's, and then it looks like this. Then you put it the t in the front of the vector, and then looks like this, and this is a straight line. This is our line of intersection. This is how it works. Thanks for watching. Practice makes perfect. Further exercises with solutions you can find on my website, which is www.worksheeps.com.